Hello, everyone, and welcome to today's episode where we embark on an exploration of the profound mysteries of modern cosmology. Imagine, for a moment, gazing up at the night sky, pondering the vastness of the universe, and wondering how it all began. For centuries, humanity has sought to understand the origins of the cosmos. And today, we're going to journey through some of the most intriguing theories that challenge our conventional understanding of reality. Let's begin with the Big Bang Theory, the prevailing cosmological model that describes the early development of the universe. According to this theory, the universe began as an incredibly hot and dense point approximately 13.8 billion years ago, and has been expanding ever since. It's a cornerstone of modern physics, supported by observations such as the cosmic microwave background radiation and the redshift of distant galaxies. However, the Big Bang Theory doesn't answer all our questions. Specifically, it doesn't explain what preceded this event or why the initial conditions were set for such an explosion. This gap has led scientists to explore alternative frameworks that might provide deeper insights into the universe's origins. One such framework is string theory, a bold and mathematically complex hypothesis that seeks to unify the fundamental forces of nature. At its core, string theory proposes that the most elementary particles aren't point-like dots, but rather tiny, one-dimensional strings that vibrate at specific frequencies. These vibrations determine the properties of particles, such as mass and charge. But string theory doesn't stop there. It introduces the concept of additional spatial dimensions. Beyond the familiar three, while we experience length, width, and height, string theory suggests there could be as many as 10 or 11 dimensions. These extra dimensions are proposed to be compactified or curled up at scales beyond our current ability to detect. Now, let's delve into the idea of branes, which are multidimensional objects within the context of string theory. Our universe might be a three-dimensional brane floating in a higher dimensional space. Imagine a vast ocean with countless membranes floating within it. Each brane could represent an entire universe with its own laws of physics. This brings us to a fascinating proposition. The Big Bang might have been the result of a collision between two branes. When these colossal structures intersect, the energy released could spawn a new universe, explaining the sudden birth of our cosmos without requiring a singular starting point from nothingness. Parallel to string theory is the concept of quantum fluctuations. In quantum mechanics, even what we perceive as empty space is teeming with activity. Particles and antiparticles spontaneously appear and annihilate in the quantum vacuum. Some physicists suggest that such fluctuations could have given rise to the entire universe. In this view, our universe is a large-scale quantum fluctuation that expanded rapidly during a period known as cosmic inflation. This idea challenges our traditional notions of causality and creation. If the universe can emerge from a quantum fluctuation, it raises the question, can something indeed come from nothing? It's a perplexing thought that stretches the limits of our understanding. Expanding on these theories leads us to the multiverse hypothesis, which posits that our universe is just one of potentially countless others. Each universe within the multiverse could have different physical constants and laws. Some might harbor conditions unsuitable for life, while others could be strikingly similar to our own. The multiverse concept gains support from certain interpretations of cosmic inflation. During inflation, different regions of space could undergo rapid expansion at varying rates, leading to bubble universes branching off from each other. As the renowned physicist André Linde said, the universe is not just the same everywhere. The properties of the vacuum may be different in different places. Considering the vastness and diversity of the multiverse, brings us to another profound topic, the accelerating expansion of our universe. Observations of distant supernovae have revealed that not only is the universe expanding, but it's doing so at an increasing rate. This acceleration is attributed to an enigmatic force called dark energy, which constitutes about 68% of the total energy in the current universe. Dark energy's nature remains one of the biggest mysteries in cosmology. Its influence raises critical questions about the ultimate fate of the cosmos. Will the universe continue to expand forever, growing colder and darker in a scenario known as the Big Freeze? Or could there be a reversal leading to a big crunch where the expansion halts and the universe collapses back into a singular state? Alternatively, some theories propose a cyclic model, where the universe undergoes endless cycles of expansion and contraction. This idea harks back to ancient philosophies and offers a captivating perspective on time and existence. The exploration of these theories isn't just a scientific endeavor, it has profound philosophical implications. It challenges our understanding of reality and our place within it. If there are infinite universes with varying laws of physics, what does that say about the uniqueness of our own? How do we reconcile the notion of multiple realities with our experience of a singular, coherent world? Moreover, the possibility that our universe emerged from a quantum fluctuation compels us to rethink the concept of creation itself. If something can arise from nothing, then the very definition of nothingness becomes the subject of intense scrutiny. In contemplating these questions, we're reminded of the words of cosmologist Carl Sagan: "Somewhere, something incredible is waiting to be known." Modern cosmology sits at the intersection of empirical science and philosophical inquiry, pushing the boundaries of what we can observe and what we can conceive. Another layer to consider is the anthropic principle, which reflects on why the universe has the conditions suitable for life. In a multiverse scenario, it's suggested that we find ourselves in a universe that supports life precisely because only such universes can harbor observers like us. As Stephen Hawking once mused, the human race is just a chemical scum on a moderate-sized planet, yet we have the audacity to seek answers to the grandest of questions. The pursuit of understanding the cosmos is indeed an intellectual adventure. It connects us to fundamental questions about existence, consciousness, and the fabric of reality. As we forge ahead with advancements in technology and theoretical physics, we're closer than ever to uncovering the secrets of the universe. Consider the role of the Large Hadron Collider, LHC, at CERN, the world's largest and most powerful particle accelerator. By smashing particles together at near-light speeds, scientists recreate conditions similar to those just after the Big Bang. Discoveries like the Higgs boson, often called the God particle, have provided critical insights into why particles have mass. Furthermore, upcoming missions like the James Webb Space Telescope aim to peer deeper into the cosmos than ever before, potentially observing the earliest galaxies and shedding light on the infancy of the universe. Yet, with each answer we find, new questions emerge. The enigmatic nature of dark matter, making up about 27% of the universe's mass-energy content, remains elusive. We can't see it directly, but we can observe its gravitational effects on visible matter, radiation, and the large-scale structure of the universe. The interplay between dark matter and dark energy adds another layer of complexity to our cosmological models. Understanding these components is essential for a comprehensive picture of the universe. As we reflect on these topics, it's essential to appreciate the humility and wonder that drive scientific inquiry. The universe is vast beyond comprehension, and our place within it is both tiny and significant. The fact that we can contemplate the cosmos's origins and fate is a testament to the power of human curiosity and intellect. In conclusion, modern cosmology invites us to view our existence in a broader context, reminding us that we are part of a vast and mysterious universe whose depths we are only beginning to comprehend. The journey to understand the cosmos is not just about answering the how, but also pondering the why. As we continue to explore, we carry forward the legacy of countless thinkers and scientists who dared to look beyond the horizon. It's a pursuit that not only expands our knowledge, but also enriches our experience of being part of this incredible universe. Thank you for joining me on this cosmic journey today. Until next time, keep looking up and keep wondering about the infinite possibilities that await in the stars above.